Hey everybody, Will here from MachineLovus.com, here with another video in the YouTube data analysis system building series. In this video, I am going to do what I promised to do last video, which is actually start using some of the data that we're collecting on YouTube videos into the DynamoDB AWS database. If you've been following along, we have been setting up the pipelines that will push data, YouTube video data, into this AWS DynamoDB database, where you get things like looks like this in the database, which will give you some of the keywords that we've been searching on data engineering versus software engineering. This title is Top 10 Software Engineering Internships with Salaries. So we want to take this data and actually start doing some cool stuff with it. So stick around. That's what we're going to do in this video. Okay, what I'm going to do is fire up a Jupyter Notebook. I do that by typing Jupyter Notebook into my console. It should come right up. So this is going to be a Python 3. Let me go into, I have a notebooks folder. Python 3, new notebook, let's start with. So what we're going to do is import Bodo 3. We are going to connect to AWS. I think it's AWS. Let's see. Let me just use my cheat sheet here. Okay, that's right. So to get to AWS DynamoDB, we use bodo3.resource. To get to our table, we're going to use aws.table, and then our table is called y videos. Okay, has no attribute table, so it's capital T. Okay, and now we could start querying this table. What I'm going to do is get a table scan, which will return, let's see how many things it returns. 450. So let's look at the keys on this response. Yeah, okay, so it's a dictionary with items count, scan count, last evaluated key, response, meta. So let's take a look at each of these. So response items, we just said, is 450 things, but the first thing is going to be our like channel count, the first item, the first record that we pulled out of our database. Kind of an interesting bit of data here under the keyword YouTube audience development. Let's look at the other keys. Response count 450, which is the len, which is the length of the count. What else do we have? We have count, scanned count. Okay, on 450 scanned. Let's see, response last evaluated key. I'm not sure what that is. Okay, I guess that's the last key. And then response metadata. Response metadata. It's lowercase. Okay, so just some metadata about calling AWS. So what are some interesting things we could do with these 450 records, because we don't know how to, exactly what we want. Let's import pandas, do our typical data science thing, and make a data frame. What's nice is that we've stored these items as a list of dictionary, that they come back as a list of dictionaries, which you can put right into a data frame. So this goes right into a data frame here, and then you can start using it almost immediately. So you can do things like You can do describe ahead. df.describe, huh? Describe doesn't want to work. Okay, describe doesn't want to work on a list. So let's do like channel view count. It's rare that describe fails on me. I think view count is the video view count. Then we have like channel view count. Okay, and then we have some information about the videos there. So we can also do some plotting. I think if we do, let's say channel view count on the X and then view count on the Y. I'm a bit off on my on my data frames plotting. I guess I need to import matplotlib now. Okay, I guess I need to do import matplotlib.pyplot as plt import. Well, I already have pandas. I don't need that. No module name matplotlib. What's nice is you can pip install from a notebook. So I'm going to let that run and install. And then I'm going to grab a example and modify it, which is what you will want to do. Okay, so I think I successfully installed matplotlib, so then I can import it, and then I could do a plot with it or not. Matplotlib is required for plotting as PLT. df.plt? No? Import mat.lib pyplot as PLT. Does not. Okay, I think what I need to do is convert my columns to numeric. Not sure why they aren't. View count. You know what? Let's do this. Okay, that was more of a grind than I wanted it to be, but there we go. Just a little, kind of a dumb little plot here. So you can do more with pandas. There's a whole bunch of things to do. And so actually now my describe is a little bit better. And it shows you the vast range that the videos in the data sets take on. I don't want to work too much in Jupyter Notebooks. They're great for certain things, but we want to build an analysis system. And so all of this work that we're putting into here is not going to be able to be used on a website in the future. There are ways to upload Jupyter Notebooks, I think, and display them on websites. It should be possible, but what I want to do is build interactive visualizations. This just shows you how far you can take things with Jupyter Notebooks. You can explore data, analyze it, visualize it. You can build models in here, which is great. Yeah, it looks like my video count is a string, also my view count. But let's switch over to D3. So where I want to get to by the end of this is to have this visualization. You'll see that as I hover over these bubbles, you can see the video title down there, and I want to show you how I made this. Now this is just kind of a dumb, also not a final form D3 visualization. It has some tweaking to do, but it's something that eventually could go onto a website and be, you know, usable to individuals who visit the website where we are going to analyze this YouTube data, which is kind of interesting. And then we can update it as data flows into our system. So let's get working on that. Here I am in the Cloud repository. I made just a little file called app.py. I could rename that. I don't actually want this to be the main app later on, but what I want to show you is that with Flask, what you can do is just pass data from Flask that we pull out. We're going to use the same table table object and the same scan that we just use in that Jupyter notebook to send data to a route. So I have, this is our route. It's just going to be load up an index.html file, and it's going to do, I'll come back to what the cache is, but it's going to do the table scan right here, the response that we just did in that Jupyter notebook. And then I munge the data a little bit. So I get the channel view count and I turn that into a log, because with data that has this kind of exponential format, we need to set it as a log so that the charts just don't blow out, because you have individuals who have very few views, and then you have individuals with giant amounts of channel views. So getting them all on the same chart without taking the log would be really difficult. So the data that we care about is the channel view count, the video view count, the channel video count. And then I have other things like the category ID, the channel title, the thumbnail, and the video title in there. And we might use those later on, so I'm just going to grab them for now. So this is the list of dictionaries that I will munge from the table scan. Okay, and then I passed, the other magic here is just the return render template, which is a Flask thing. Pass this data to index.html. Now, all of this is fine, but I was debugging this and I didn't want to load the data again. So I put this dumb simple cache in place. So the cache is just a list. It's a global variable. And so if the cache doesn't exist, if it's empty, if the list is empty, then I'll populate it with this data. Otherwise, the data that I'll be sending is from the cache. And what this allows me to do is just save, not hitting AWS with a scan every time I reload my chart because I want to modify something on it. Maybe it's unnecessary, but that's what it is. So then you just do name equals main app.run. So let me just show you. So I have my Jupyter notebook running there, and then over here I have Python, just Python app.py. I see that this is the port that it's running at. This is the location that it's running. Okay, and then when I reload, do a hard refresh here, I should see that I'm not loading the data again. So the cache was populated, and then I didn't load the data again. Okay, so how do I have a chart there? So this is the little Flask route. This gets the data from our AWS database, passes it via render template to index.html. In the future, we'll use Vue.js, and I haven't figured out yet how all of this translates over to Vue, but we will have to do that. So here I have an index.html file. Okay, so index.html lives in templates folder, and then index.html, otherwise I wouldn't be able to find it. So let me get rid of all of this stuff for now. I'll just comment it out. So all of this is commented out now. And so when I reload this, I get nothing, right? So there's nothing here. This is what you'd see if you're just following along and you made an index.html that's blank, essentially blank. So let me step through the top levels of this. We have, okay, let me just put this down here. Okay, so here we are loading D3, one of the latest releases. It's sort of a V4 they have. So what I'm gonna do just to start this off is to uncomment out the data piece of this, and then keep the other pieces commented out. So right here, var data.toJSON safe. So this is where we grab the data that we pass from Flask in our JavaScript, and then I log out the data. So just saving that little small piece, what you see, you don't see anything, but if you go to developer tools, which I'm using Chrome, and developer tools is extremely useful here. Now what we have is an array over here. So this is all of our JSON data, all of our data from AWS that's sitting available for use in our console to make a bubble chart or whatever D3.js thing that we want to make. Or if we wanted to use some other system, this would be our data right here. So all of this data is now available to us to use in the front end. Okay, so the rest of this code, I don't want to go through it in depth, but essentially what I'm doing is taking some D3.js code, and there's a lot of D3.js code available out there. A lot of it is readily available online. You just look up like D3.js bubble chart, and what you get are things like this bubble chart here, where all of the data is just available. All the JavaScript code that we need to use is available. All you need to do essentially is know how to sub in the data that we have passed to the front end for this data. And you can use all sorts of D3.js visualizations, and there are a lot of them. So if you just go over to D3.js and look, there is all of this fantastic stuff that you can do with data. You just need to figure out what kind of chart you are interested in, and then you can use it once you figure out. So this is the data that they're using, and it's arrays, right? So this resembles almost the kind of data that we are using here. So what did I do? I did something similar to grabbing some of this information and then spending a lot of time manipulating it and tweaking it to get the chart that I did. So I think right now I have some sort of error. So I have an error in index. So you go through and using Google Chrome tools. Make sure you guys can see this. So using Google Chrome, you see the developer tools, you can see where the errors are in the D3 data that you are essentially copying over and manipulating for your own personal use. The trick to a lot of this D3 stuff is knowing how to get your data into a format that D3 wants. And once you figure that out, you can essentially make whatever you need to make. So this says, set the dimensions and margins of the graph. This is a comment that I uncommented out. So I re-comment that, and our chart is back. in the format that we want. So here I did a bunch of tweaking. If I didn't use that log scale that I turned the data into logs before passing it over here, this would be really way out of whack. If you just used a linear scale here, you basically would only see one of these dots, and then the rest of the dots would be far spread away. But turning it into a log form, you can see the relationship here. So this x-axis is the channel view count. The y-axis is the video view count, and the radius of the bubbles are the channel video counts. So larger bubbles are YouTubers who make a lot more videos. If you go over here, you get people who have a lot of views on their channel, and up is a lot of views on the video. So there's a direct relationship there. And you see, as you get you can sort of eyeball at that as you move to the right, as you get YouTubers who make a lot more videos, then they get more views generally. Likewise, over here you get, the really small dots have very limited number. The bubbles aren't that big, so they are not making as many videos. But what's neat is that if you, as you hover over, wait a second, as you hover over the data, you should be able to, no, maybe not. I thought I'd be able to see and hear the data that is actually being referenced. Anyway, this is the D3 chart that I pulled together, just sort of using going to blocks, or there's this d3graphgallery.com where you can look up the different kinds of D3 charts that you can make. This is just one, and it's one that, with some tweaks, what I'd like to do in the next video is get onto a website that's deployed so that the website will show, let's say for certain keywords, this is just a table scan, a visualization like this that users can start interacting with, and that maybe we could start providing value from this YouTube analysis system that we're just starting to build and starting perhaps to make useful.